A very good day to all of you. Today we are going to start a new chapter in PSCAD on the topic of simulation of flash drum, heaters, coolers and also heat exchangers. We are going to split chapter 2 into two sections. First section will be focusing on flash drum and second section will be focusing on heat exchanger, including heaters and coolers. So for this session, we'll focus on the topic of flash drum. And upon the completion of this session, you should be able to introduce the vapor liquid separation process and able to simulate a flash drum. A little bit revision that we should go through about flash drum, and I believe most of you have learned it in unit operation. A flash drum is actually a single equilibrium stage distillation, and it is normally used to separate liquid and vapor phases based on the principles of relative volatilities and also vapor liquid equilibrium. It's just like the principle used in the distillation column. And say if we are having feed consists of only liquid, we need to push it through a heater to generate a mixture of vapor liquid before it is pushed to a flash drum. Okay, so if you look at here, vapor will turn up as the top product, and in your bottom product you are going to have the liquid. So let's continue about the flash drum, a little bit more detail. So as I mentioned before, it is used to separate a vapor liquid mixture. So the feed should consist of either two liquid and vapor or a liquid and vapor. So normally we will have a liquid and vapor, not a problem. But what is actually two liquids and vapor? So two liquids here are referring to say in your feed you are having two components. When it is in liquid phase, it is actually immiscible, meaning these two liquids are not mixed together. When you put it together, two layers are formed. Okay. So this separate the component provided that the temperature is chosen before the boiling temperature of the component, and of course at certain pressure. Okay. So the degree of separation depends on, first, the composition of the mixture, second, the concentration of certain species in the mixture, and third is relying on the temperature and pressure of the flash drum. So typically, if you want to perform a manual calculation for the product composition that you can produce from flash drum, you can use the Rashford Rice procedure for isothermal flash calculation. And when you do this calculation, you actually assume that the K values, the relative volatilities here, are actually independent on the composition. So I wouldn't go through because this is for your manual calculation. And with Xpen Plus and with the flash vessel model in Xpen Plus, you do need to perform the manual calculation, but you just need to apply the model in Xpen Plus to aid you in calculating the product composition of a flash drum. So these are the model available in Xpen Plus that represents a flash unit. So we have flash 2 and flash 3 to focus on. So the rest with the basic in using flash 2 and flash 3, you are able to apply it on your own later on in your plant design. So flash 2 here meaning you are having two product, two referring to two product, one vapor and one liquid, and it is commonly used to separate feed with a mixture of one liquid and one vapor. Okay, meaning a liquid and vapor. So flash 3 here meaning it is used to cater a vapor liquid equilibrium, meaning you are having two liquids plus vapor, and these two liquids must be immiscible. Okay. 3 means you are having 3 products. You have 1 vapor product and 2 liquids product at the bottom. This is a flash to flow sheet connectivity. So typically, once you put in the model, once you choose the model, either is flash 2 and flash 3, okay, you have to put in the stream, material stream. So the red color cursor here, okay, the red color arrow is the location that you must put in the stream. So as in flash 2, you must put in 1 feed and 2 product, okay, 1 vapor and 1 liquid. As in flash 3, you need to put in 1 feed but 3 product, as I mentioned earlier. So you have 1 vapor, 1 liquid for the top layer, because it's immiscible, right? So you have top layer and bottom layer. So the third product is for the bottom layer liquid. And say if you are having oil plus water, so water will be at the bottom and the oil will be your top layer. So other than the material streams, you can also put in heat streams if you wish to, but heat streams are actually optional. So blue color arrow meaning it is optional, and red color here is a must, you must put in. So in X1 Plus, once you have put in the list of components, select the appropriate thermodynamic model, then you choose the model, you put in the stream, then you put in the stream information, the feed information especially, then you need to include the flash specification, and typically you need to either include 2 of these. So you have temperature, pressure, vapor fraction, and also TUT. You only need to put either 2 of these. Okay, 4 out of 2, you have to choose 2. Okay, once you put in the information about the operating condition, then you can actually proceed for the simulation. So I think that's it about the principle of the separator, which is flash drum. So we'll stop here for a while before we proceed to exercise 2.1. Thank you very much.